tell me the zeros. Part C, does the graph bounce or go through each zero? So I would list it out. So when we graph polynomials, I am fully aware you can plug it in the graphing calculator and get a sketch of the graph. But we want to be able to be a little more precise about that. What are you doing, Quinn?
Well, these are.
Don't look like you're paying attention.
I'm paying attention.
Okay. We need to make sure we're factoring it first, and then we can find the zeros because we've done that before. When it's in factored form, it's just what makes each parenthesis zero. We're going to decide if our graph will bounce or go through at each, which we mentioned yesterday has to do with your multiplicity. Even multiplicity will bounce, odd multiplicity would go through. We can determine our end behavior. That's based on that leading term. We can find the y-intercept, and if we put all that stuff together, we can get a sketch of our graph without ever picking up a calculator. Now your calculator can definitely check your work, but these are all questions you should be able to answer just by looking at an equation. So if I told you to sketch this graph by hand, first thing we have to do is find the zeros. Now lucky for us, it's already factored. So we can just go ahead and list our zeros. And if you've misplaced your handout, you can just do this in your notebook so you've got notes somewhere. Alright, what are the zeros on this one? Positive 1/2. Okay, does everybody know where she got those? Just set each parentheses 0. None of those are all to the first power, so we don't have to worry about our multiplicity. The next question I'm going to ask, does your graph bounce or go through with each of those? So they all have a multiplicity of 1. 1 is odd, so what's the graph going to do? Go through. So I just usually list them underneath them. Okay, next step, let's find our end behavior. Okay, so in behavior, we have to think about if I multiply this out, you would have 2x times x times x. So we would get a 2x to the third. So what's your end behavior going to be? Down, up. Let's find our y-intercept. What's a y-intercept? Where it crosses the y-axis. What's true about x if you're on the y-axis? X is 0. So if you go to your equation and plug in a 0 for all your x's, you get -1 times 1 times 3, which gives us -3. This is really all the information we need to get a rough sketch. My zeros are the same thing as x-intercept. So I'm going to touch the x-axis at -1, -3, positive 1/2. Touching the y-axis at -3. My graph is going to start down here and end up here. So if I'm starting down here, we hit the -3, and we said the graph is going to go through. Goes through that point. You have to come back down at some point to hit your 1, and we said the graph is still going to go through. Okay, you got to go through the y-axis, that's your y-intercept. Come back to the 1/2, and we said you go through. My graph ends pointing up. So here is a rough sketch. Now, is this 100% exact? No. All of my intercepts are correct. My ends are going the right direction. Now, it's possible that the graph might look we've got the correct shape. That's what I'm looking for here. A couple things. A polynomial is a nice, smooth curve, so you shouldn't have any corners in it. It's all just a curve, nice and smooth. No breaks in your graph, no corners, nothing like that. What questions do you have right there? Yeah.
How do you figure out the root?
You look at the multiplicities. So all of these were to the first power. Multiplicity is 1. Odd multiplicity will go through and even bounces. So if one of them had been a squared, you would bounce off of it. Other questions? Sure. This one. So we're going to do all the same stuff that we did in the last one, but then I have some additional questions that we're going to answer. Let's start. This one is not factored, so we're going to have to do a little more work. What's our end behavior? We can do that first. Up. Now, it's not factored. We need it factored to get our zeros. What do you want to do? Do we have an option for factoring polynomials? P's and Q's and synthetic division. So where do you find your P values? Constant. -16. So plus or minus 1, 2, 4, 8, and 16. Where do you get your Q values? First. So that's a 1x to the 4th, so plus or minus 1. So the possible zeros, that's P over Q. And what do you get? All the P values. Okay. Now what do we do? Yeah, find one that works. Find one that makes it 0, or looking at a graph, where does it touch the x-axis? What works? You guys can find it. I'm not going to tell you. What'd you get? -2 works, okay? So once you find one that works, we do our synthetic. What did I do wrong when I wrote this? We don't have an x squared, so we need a 0 for our squared. Okay, so 1 comes down, so it's going to be -2. We get x cubed minus 4x squared plus 8x minus 8. Can we do that? No. So what are we going to do? Synthetic again. So find another one that works. +2. And so I get x squared minus 2x plus 4. All right, is there anything that multiplies to 4 and adds to -2? No. So what am I going to have to do to finish this? Quadratic formula. It's a long one. So opposite of b would be +2 plus or minus the square root of b squared minus 4ac all over 2a 2. Square root of negative 12, you could break it into 4 and 3, so you get 2I radical 3 all over 2. So that's 1 plus or minus I radical 3. This whole point was to find our zeros. Now you can list all of these, but when I go to graph, I am only wanting these zeros so I can graph them. Can you graph 1 plus I radical 3? No. So if you want to list it, you can. If you want to leave it off because you recognize it's imaginary and we can't plot an imaginary x-intercept, that would be okay as well. So which ones do work? Negative 2 and positive 2. Okay, both of those just worked one time. Multiplicity is 1, so for both of them, the graph would go through. Y-intercept. If you plug in a 0 for x, what do you get out? Okay. This is what I need to graph it. My graph should start up here and end up here. And touch the x-axis at negative 2 and positive 2. The y-axis at negative 16. Count by 4s. So my graph has come down. It hits negative 2. We go through it. Come down and hit your negative 16. Come back to negative 2. We go through. And so it ends up like that. Questions there? I asked some additional questions on this one. I also want to know the x-intercepts. What are x-intercepts? Same thing as zeros. You would only need the positives because you're only really touching the x-axis of the positives. I asked where p of x is less than 0. Where is this graph less than 0? Less than 0 means below the axis, so that happens on this little section of it. So it's between those two zeros. It's on the interval negative 2 to positive 2. It equals 0 at positive and negative 2. Below, in between those, you're below. So where is the graph greater than 0? You're above the axis here and here. So that's negative infinity to negative 2 and positive 2 to infinity. So those last questions you could answer just by looking at the graph you had drawn. Yes, Bryce?
Do we have to use brackets with those?
No, because at the positive and negative 2, it equals 0. If I put an equal to right here, then they would need brackets, but otherwise you would not. Other questions? We're going to do a few more of these. We can determine our end behavior from the beginning if you want, and then we're going to have to factor this thing down to find our zeros. So the end behavior is probably easiest before you factor it. You just look at this negative 2x cubed. What does that tell me? Normal x cubed is down up, but the negative would flip it. So it's going to be up down. So remember, odd powers look like x cubed. Even powers look like x squared, and if you have a negative coefficient, that flips it. Okay. If I go to do p's and q's, I have an issue here. What's my constant? 0. What, we can't really do factors of 0. But what could you do on this polynomial? Not factor out -2, but what do they all have? X. Let's plot a negative x. I'm pulling out the negative just because I like my first term to be positive. If you take out negative x, you're left with 2x squared plus x minus 1. Can we factor that? We could do box method. Okay, so I need two things that multiply to -2 and add to +1.
Two in there.
Thank you. Factors, we get 2x minus 1, x plus 1. So now we can list our zeros. What makes a negative x equal 0? 0. What makes 2x minus 1 0? And x plus 1? All of those are to the first power, so what do you know is happening at all of them? Going through. Odd powers go through. Next thing we need is y-intercept. If you plug in a 0 for all of your x's, what do you get out? 0. Okay, so my graph should start up here and end down here, touching the x-axis at -1, 0, and +1/2, touching the y-axis at 0. So we're going through all of those, so we hit this, go through, hit that one, go through, hit that one, go through. My graph looks something like this. And do just a couple more, and then we'll be done. Alright, on this one. In behavior, you have to think about if you multiply this out, you would end up with an x squared in the first parenthesis, an x cubed in the second one, so altogether you get x to the 5th. So what's your in behavior? Down. Zeros, a little bit easier on this one, it's already factored. What would make x minus 1 0? 1, but that square means multiplicity 2. X plus 2, that would give me multiplicity 3. To decide if you bounce or go through, you are looking at whether the multiplicity is even or odd, not the 0, the multiplicity. So multiplicity of 2 means we will bounce. Multiplicity of 3 means we will go through. Y-intercept, if you plug in zeros for all of your x's, you get 1 times 8, which is 8. So, should have a graph starting down here, ending up here. Touch the x-axis at -2 and +1. The y-axis at +8. So if I hit at -2, my graph is going to go through, gotta hit your y-intercept. What happens at 1? Bounces. Come back like that. Make sure when you're drawing these graphs, it is a curve. You have to touch the x and y axes at the points that we've designated, and only those points. If your graph hits it somewhere else, you've made a mistake. Is that one okay? Why don't you guys try the last one on your own? Okay, so in behavior, if you multiply this out, you have an x to the 5th times an x times an x to the 4th. So overall, you get an x to the 10th. So what's it gonna look like? Up, both ends pointing up, it's gonna be like x squared. Your zeros, this one's going to give us 0 multiplicity 5. This one would be 3, and this would be -4 multiplicity 4. Are we okay there? So at the 0, multiplicity of 5 means we will go through. 3 had a multiplicity of 1, so that one will also go through. Multiplicity of 4 means you bounce. Y-intercept, if you plug in a 0 for your x, you get 0 out. So then if we plot all this, my graph should start up here and end up here. So we've got to come down, hit -4, but we bounce, come back and hit 0, which goes through, hit 3, and go through. And so my ends both end up pointing up like we anticipated there. Any questions? My plan was to give you guys a little bit of time to work so that if you were having any problems, you'd have a chance to ask any questions in class. So you're doing 30 through 46 every other even, or if you prefer to write them out,